Imagine a world so distant that it takes light over 5 hours to travel from the Sun to its surface. Welcome to Pluto, the dwarf planet that continues to defy our expectations with its icy mysteries. Ever since NASA's New Horizons spacecraft flew by in 2015, our understanding of this remote and frozen world has been completely transformed. But what is it that makes Pluto so fascinating, so utterly unique compared to the rest of our solar system? In July 2015, after a 9.5-year journey spanning more than 3 billion miles, NASA's New Horizons spacecraft made history. It became the first human-made object to perform a close flyby of Pluto, sending back images and data that stunned scientists and space enthusiasts alike. What we learned from this flyby changed our perception of Pluto forever, revealing a world far more complex and dynamic than anyone could have imagined. New Horizons was designed to uncover the mysteries of Pluto and its largest moon, Charon. As it sped past at a breathtaking 31,000 miles per hour, the spacecraft's instruments captured high-resolution images and detailed measurements, providing a wealth of information. Before this mission, Pluto was a pixelated blur in the eyes of astronomers, but New Horizons transformed it into a vivid, detailed world, complete with mountains, vast plains, and peculiar atmospheric features. One of the most iconic discoveries made by New Horizons was the heart-shaped region known as Tombaugh Regio, named in honor of Pluto's discoverer, Clyde Tombaugh. Stretching over 1,000 miles across, this icy plain stands out not just because of its distinctive shape, but because of what might lie beneath. Scientists believe that deep beneath this frozen surface, there could be a slushy, liquid water ocean, a shocking possibility given Pluto's frigid temperatures, which plunged to -375 degrees Fahrenheit. How could such an ocean exist in a world so cold? The answer might lie in the insulating properties of Pluto's icy crust, combined with heat generated from radioactive decay within the planet's core. This potential subsurface ocean has ignited a wave of speculation about whether Pluto could have, or perhaps even still does, harbor some form of microbial life. It's a tantalizing thought, a hidden ocean, frozen in time, preserving secrets from Pluto's ancient past. And if that wasn't astonishing enough, evidence suggests that Pluto's surface once hosted lakes of liquid nitrogen. Imagine vast expanses of nitrogen-rich water flowing across the icy plains, only to freeze solid as temperatures dropped even further. These lakes now lie frozen, a haunting reminder of a time when Pluto's climate may have been far more active. Understanding these ancient nitrogen lakes provides clues about the planet's history and how its environment has changed over the millennia. Pluto's atmosphere is one of its most remarkable features. Although it's incredibly thin, just 1/100,000th the pressure of Earth's atmosphere, it's surprisingly dynamic. A thin, blue haze envelops the planet, created when sunlight interacts with methane gas in the atmosphere. This sunlight triggers chemical reactions, producing complex hydrocarbons that form a smog-like haze, which then drifts slowly downward, coating the surface in a reddish, organic frost. This haze gives Pluto an almost ethereal appearance, with layers that catch the sunlight and scatter it in a beautiful, blue glow. It's a sight that makes you realize just how alive Pluto's environment truly is, even at the edge of the solar system. These complex atmospheric processes are a reminder that even the most distant worlds can surprise us with their vibrancy. Pluto's stunning mountains rise majestically from the icy plains. These aren't ordinary mountains made of rock, but towering peaks composed of solid water ice. Why water ice, you ask? Because on Pluto, water behaves more like rock, remaining frozen solid at the planet's extreme temperatures. The tallest of these mountains reach heights of up to 2.2 miles, comparable to some of the highest peaks on Earth. But what's truly fascinating is how these mountains are shaped. On Earth, mountains are often formed by tectonic activity, but Pluto's mountains have been sculpted through a process called sublimation. Sublimation is when a substance transitions directly from a solid to a gas without becoming liquid. In Pluto's case, the icy peaks gradually lose mass as nitrogen ice on their surfaces sublimates, shaping the mountains into jagged, rugged forms over millions of years. Pluto's surface isn't just mountains and plains, it's also home to vast fields of dunes. Yes, you heard that right, deserts on a frozen dwarf planet. These dunes aren't formed from sand but from tiny grains of nitrogen ice. Scientists believe that winds, driven by Pluto's thin atmosphere, carry these nitrogen particles across the landscape, creating formations that resemble the deserts of Earth. What's even more astonishing is that these processes occur despite the planet's weak gravity and low temperatures. Understanding how these dunes form offers valuable insights into the physics of low-gravity environments. It's a unique example of how natural forces can operate under extreme conditions, shaping a landscape in ways we're only beginning to comprehend. It makes you wonder what other unexpected features await discovery in the outer reaches of our solar system. And if deserts on a frozen world aren't strange enough, consider this: Pluto has iceberg-like structures floating on its surface. These massive chunks of water ice drift atop a slowly churning sea of frozen nitrogen, driven by a process known as convection. Heat from Pluto's interior causes the nitrogen ice to rise and fall, creating a slow but constant movement beneath the crust. As a result, these icebergs glide across the landscape, a silent testament to the planet's inner activity. This process reveals that Pluto is far from a static, frozen wasteland. Instead, it's a world where even the ice flows and moves, reshaping the landscape over time. The existence of such active geological processes so far from the Sun challenges our understanding of what icy worlds are capable of and raises questions about the dynamics of other distant bodies in the Kuiper belt. When you put all these features together, Pluto's geological history becomes a captivating tale of change and activity. From ancient nitrogen lakes to modern-day wind-sculpting dunes, each piece of evidence tells a story of a planet that has been more dynamic than we ever imagined. It's incredible to think that a place so cold and so far away could have experienced such a rich and active past. Then, there's the possibility of cryovolcanism. Pluto's surface features include what could be massive cryovolcanoes, like Wright Mons, which stands nearly 3 miles high. Unlike Earth's fiery volcanoes, these icy giants may have erupted with slushy mixtures of water, ammonia, and other ices. These cryovolcanic eruptions would release material so cold that it would freeze almost instantly, creating frozen flows that shape Pluto's surface in ways we're still trying to understand. Cryovolcanism isn't unique to Pluto. We've seen hints of it on moons like Europa and Enceladus, but on Pluto, it takes on a whole new dimension. The existence of these icy volcanoes adds yet another layer of complexity to our understanding of the solar system's outer reaches and invites comparisons with other icy worlds. As New Horizons continues to send back data, scientists are already looking ahead to the next great adventure, exploring more of the Kuiper belt. This region, full of icy worlds and untold mysteries, holds the keys to understanding the origins and evolution of our solar system. Pluto's secrets are far from fully revealed, and the more we learn, the more questions arise. Pluto's strange surface reminds us of how little we truly know about our cosmic neighborhood. It's a world of frozen nitrogen lakes, towering ice mountains, and windswept dunes, all shaped by forces we're still trying to comprehend. If you're as fascinated by the mysteries of the universe as we are, don't forget to hit that subscribe button. Join us on this incredible journey as we continue to explore the wonders of space. Who knows what other astonishing worlds are waiting to be discovered just beyond the horizon? New Horizons' mission didn't just stop at Pluto. It continued its journey deeper into the Kuiper belt, exploring regions that remain some of the most enigmatic in our solar system. The Kuiper belt, a vast expanse of icy bodies orbiting the Sun beyond Neptune, is home to countless dwarf planets, comets, and ancient remnants from the early solar system. Each of these objects holds clues to the processes that shape the planets we know today. By studying Pluto and its neighboring worlds, scientists are piecing together a more comprehensive picture of how the solar system formed and evolved, revealing a history rich with cosmic drama. One of the most intriguing aspects of Pluto's continued study is the potential it holds for future space missions. Scientists have proposed returning to Pluto with a lander or orbiter to explore its surface and subsurface in even greater detail. Imagine a spacecraft capable of drilling into the icy plains of Tombaugh Regio, sampling the frozen layers, and perhaps even detecting signs of past or present microbial life. Such a mission would be a technological marvel and could redefine our understanding of what life needs to survive. The thought of uncovering life in such an unlikely place continues to drive scientific curiosity and exploration. But why is Pluto's study so important for our broader understanding of planetary science? The discoveries made on Pluto challenge our assumptions about what makes a planet active or geologically dead. Before New Horizons, scientists expected Pluto to be a frozen, lifeless rock with little to offer in terms of geological features. Instead, we found a world where ice behaves like rock, where nitrogen flows like rivers, and where mountains are slowly eroded by sublimation. These unexpected findings remind us that our universe is full of surprises and that even the most distant worlds can be full of wonder and complexity. As we reflect on Pluto's many mysteries, it's clear that the dwarf planet has a story to tell, one of resilience and change, shaped by forces that we are only beginning to understand. From the possibility of an ancient ocean beneath its icy crust to the winds that continue to shape its dunes today, Pluto remains a beacon of intrigue in our exploration of the cosmos. Every discovery made there paves the way for future missions, not just to Pluto itself but to other icy worlds that could hold the keys to life's existence beyond Earth. As we continue to look outward into the universe, Pluto reminds us that even in the coldest, most remote corners of space, there is still so much left to discover.